So welcome to this first video on Trigonometry 1 at AS level, and the first thing we're going to look at is the Cosine and Sine Rule, focusing on finding the missing sides and angles in non-right angled triangles. Now for those of you who did high GCSE, the good thing to note is that this is no different to what you've been taught before. So all we're going to do in this video is go over what the Cosine and Sine rules are, how you use it, and some examples of how we can use those rules to answer those questions. So let's get started. So we use the cosine and the sine rule in a similar way to how you would have used SOHCAHTOA for right angled triangles. However, when your triangle is not right angled, then you'd have to either use the cosine rule or the sine rule to find the lengths of missing sides or what the size of missing angles are. Now the first we need to look at is the triangle. Now when we're looking at this particular triangle, note that each angle is represented by a capital letter, and again obviously just labeling this as ABC, and their opposite angle, the opposite sides to those angles are the lowercase version. So if this here is angle A, then the opposite side will be classed as lowercase a. And likewise, if we had here, we've got angle B, so we label that capital B, and its opposite side is lowercase b. And here, let's get a different colour pen, and let's go for orange. So here we've got angle C, and the opposite side to that is going to be lowercase c. Now there are two, as we said, there's two rules. We've got the cosine rule and the sine rule. Now for the cosine rule, it's usually written in two formats, but they are both the same thing. It's just one is a rearrangement of another. So for the cosine rule, this variation is, as the subject is a squared, we use this when we are finding a missing side, and we use this variation when we're trying to find a missing angle. So for the cosine rule, there's two variations, but it is still the same format, and it's just a case of rearranging to make it so. And the reason why it's written in two different formats is because, as it's mentioned, when in this topic, all you're doing is either finding an unknown side or an unknown angle, in which they're your two formulas. Now for the cosine rule, there is just one formula for this, and it's only written usually in one format. Now if you look on any website or any revision guide or any textbook, you might find that the side A over sine A might be flipped. So you might have the formula written as sine A over A equals sine B over lowercase b, and sine C over lowercase c, but they're both the same formula. Now with regards to the sine rule, this is used for when you're finding both the missing side and missing angle. Now the reason why they write it in two variations is usually this is the version you would use when you're finding a side, and this would be your version of when you are finding a missing angle. However, with the method I'm going to show you, we're just going to remember it as one way. Now the key thing to note with the sine rule is that you only ever need to use two of these three fractions. So in one aspect, what you can do is scrap off the c sine c and just use this rule in this format. And that's what, in the examples, that's the method we're going to use. So moving on from that, a very sort of common question that gets asked when teaching this is, when do you know when to use each of the two rules? So for this is based on the information that's given to you in a question. So when you are given a trig question where you've asked to find a missing side or a missing angle, and it's a non-right angled triangle, look at the information that's given to you. So if you are given three sides and one angle, where one of them undoubtedly is going to be the unknown, or the x as we say, then you use the cosine rule. Okay, so when you know three sides and one angle, you go for the cosine rule. And if you are given two sides and two angles, then what you do there is you use the cosine rule. So in the examples that we show, there's going to be no indication about which rule we use, but I will go through how I decide which one it's going to be. Now, these steps is just a key thing of how we go about answering any question that's revolving this cosine or the sine rule. And I'd always encourage students to follow these 4 steps. Now, either you write these 4 steps down in terms of your layout of how you present your answer, or you can do some of these mentally. But I would say you're less likely to make any silly mistakes if you do follow these 4 steps. So the first thing you want to do is label the known sides and the angles of the triangle. So always remember that they're in the format of the triangle. The angles are represented with capital letters, the sides are represented by lowercase letters, and each letter is opposite the other. Always start by labeling the unknown, or x in this case, as a if it's an angle, capital A rather, if it's an angle, or lowercase a if it's a side. Always start with a's, because if you look at the format of the formulas, a is usually the subject. Now the second step is then you need to pick the correct rule. So as I've mentioned before, if you're given 3 sides and an angle where one of them is x, you use the cosine rule. If you've got 2 sides and 2 angles, then it's going to be the sine rule. So that's you deciding which one it's going to be. Now for step 3, just if you're starting off or haven't had much practice, or you're not that confident in this particular topic, then I would strongly recommend that you start by writing down the formula you're going to use, and then substitute the values correctly into those. So it might be worth noting what your capital A is, what your lowercase a is, what your B, what your C is, and substituting that into the formula, and so you know what you're working with. And then the final step is to calculate and round with units. So make sure that you're entering your calculator correctly. Make sure you round your answer to if they've specified what they want the answer written to, so 1 decimal place, 3 significant figures, and also don't forget the units. Now, as a little tip, don't forget that when you're using the cosine rule, don't forget that if you're trying to find the side, you square root. And if you are trying to find an angle, don't forget to inverse cos or inverse sine. If you look at the formats of how the formulas are written, they're written with cos A, you'll have cos A the subject or sine A the subject. And if what the question is asking you to do is to find out what angle A is. So don't forget to inverse cos or inverse sine it. And then when using the sine rule, remember that when you are finding an obtuse angle, to subtract the calculated answer from 180. And this is what we call at GCSE level an ambiguous case, in which in one of the examples I will talk you through that if you're not too sure. So there are a couple of things to make note of, and what we'll do now is we'll go through some examples, and I'll kind of refer to these 4 steps so you get more of an understanding of where we use it and what we use it for. So let's get started on this first example. So in this first example here, let's have a look. So we're going to label this. So the first thing we're going to do is we're going to start by choosing a decent colour. So let's go for purple. Right, so here we're going to start off. Now, as the first step is we label the triangle first. Now, as you can see, x is a side. So I'm going to start by labelling that lowercase a, which therefore means that this angle here is going to be capital A. And then the other 2 sides, doesn't really matter what I label them as, because I know that it's going to be B and C. There we go. Now in this particular case, that's step 1 done. Now step 2 is we now need to pick the correct formula. So as you can see in this, I've got an A, I've got a B, I've got a C, and I've got a capital A. So I've got 3 sides and 1 angle, which ultimately says I need to use the cosine rule. So using the cosine rule and knowing that I'm trying to find a side, the rule I'm going to be using is a squared equals b squared plus c squared minus 2bc cos A. Now, one little tip that I would strongly recommend that you do before we start substituting this in is, for some reason, I always recommend you put brackets around the 2bc cos A. For some reason, when students type this into the calculator, if they do make a mess up in substituting the values in, that is where they mess up on. Because they're too trusting in their calculator, it's just recognising that you've got minus 2bc cos A and treat it as one little thing. Because all of this is being subtracted by b squared plus 4c squared, not just the minus 2bc. So for some reason, sometimes if you've got a decent calculator and you're quite competent on your calculator, you don't need to put the brackets in, but I strongly recommend that you do. So for step 3, what we then need to do is to substitute the numbers in and go from there. So let's just make this pen a little bit thicker so you can see it. There we go. So we've got x squared equals, and it's going to be 6 squared plus 10 squared minus 2 times 6 times 10 times cos 87 and just put brackets there. And if you enter that all into your calculator, you get So with this example, the first thing we do is follow step 1. So step 1 says that we need to label this triangle. So we're going to start with x. As x is a side, we're going to label that as lowercase a. So its opposite angle is going to be capital A, and our two other sides we're just going to randomly label as B and C. So writing down the information that we know, so we know that capital A is 87 degrees, lowercase a is x, B is equal to 6, and C is equal to 10. So as you can see it, as we've got three sides and one angle where one of them is x, we're going to use the cosine rule. Now, in terms of, so that's step 2 sorted. So the next thing we need to decide is what variation of the cosine rule are we going to use. Now, as x is a side, the variation I'm going to use is a squared equals b squared plus c squared minus bracket 2bc cos a. Now the reason why I use brackets, as mentioned, is the fact that just to make sure I'm not making a silly error when I'm typing this into my calculator. So substituting numbers in, what do we get? We get x squared equals, and it's going to be 6 squared plus 10 squared minus 2 times 6 times 10 times cos 87. Now, as I'm working that out, what's also worth paying extra attention is the fact that your calculator is in its right angle mode. Now, when you're dealing with this, now it might be different when you're doing A2, or if you move on to from your maths, where you're dealing with different units of angles. It's worth just double checking, make sure you've got little d, or that your angle setting on your calculator is measured in degrees and not in any other variation. So if that's the case, just change the settings on your calculator to make sure that you've got the right. Now to check if you enter that the calculation in, you should have that x squared equals 129.719 blah blah blah. Now we've not worked out we've not finished the angle, because there's no way, looking at the numbers that we've got in the sides of the other two sides of the triangle that we've got 6 and 10, is x going to be 129.7 centimeters. So common sense should prevail in the fact that there's something more that we need to do, and what that something is to square root that number. Now it is also important that you don't round off your answer here, so I'm not going to do the square root of 129.719. I'm actually going to use its raw value. So what you might be worth doing is actually entering square root of ands on your calculator. So if I do that, so press square root of ands equals, and I get that x is going to equal 11.389455, which rounded to one decimal place as requested in the question is 11.4 centimeters. And I'm just going to write down one decimal place as a little reminder to myself. So moving on to the next question, let's have a look. So here, so again, I'm going to start off by labeling my triangle, starting with the x. So x, this case, is a angle, so I'm going to label that as capital A. So 12 is going to be lowercase a, and my two other values are going to be b and c, as they are sides respectively. So from this, I know that capital A is x, lowercase a is 12, b equals 8, and c equals 4.5. So again, as you can see, I've got three sides and one angle where one of them is x. So again, I'm going to use the cosine rule. Now, from that, and I'll just label the points. So from this, what I'm going to do now, as a is an angle, I'm going to use this variation of the cosine rule, just so that I don't have to worry about, got a bit away of myself there, so minus a squared over 2bc, and then so all I'm going to do now is substitute these numbers into that formula, and so I can then type it into my calculator. So I've got cos a equals, and it's going to be 8 squared plus 4.5 squared minus 12 squared, all divided by 2 times 8 times 4.5. Now if I type that into my calculator, what I should have, and again at this point, if your calculator's got a fraction button where you can enter fractions as they are without using the division symbol, I definitely would opt for doing such that. And it's also worth that, even though you know what 8 squared is 64, it might be worth getting good practice just to type in what that is, because like I said, you want to try and limit the number of mistakes that you are liable to make when using your calculator. So in this we get a cos A value of minus 239 over 288. Now, don't be too concerned with the fact that we get negative numbers as our answer for cos A, because what I now need to do is to do the inverse cos of minus 239 over 288, which is going to equal x. And if I do just that, or again using your calculator efficiently, we do the inverse cos of the answer. So if I type that in, so inverse cos of the answer equals, and we get an answer of 146.1 degrees to 1 decimal place. So moving on to our third example, which we've got here. So again, I'm going to start off by labelling my triangle. So as you can see, x is a side, so I'm going to label that lowercase a. I'm going to label this capital A. This I'm going to label as B and capital B. And this I'm going to label as lowercase b. Now note that as it mentioned in the methods and the steps is we don't bother labelling empty sides. So I'm not going to label this capital C and this lowercase c because they're both blank. I've got no information at all, whether it would be a number or a letter, so I'm just going to leave it blank. So the next thing I then need to do is write down what information I've been given. So I know that I've got A equals x, capital A equals 42 degrees, B equals capital B equals 57, and lowercase b equals 8. So as you can see here, I've got two sides and two angles where one of them is an x. So in this case, what I need to do is use the sine rule. Now, the variation of sine rule, I'm just going to use two of the fractions. So I've got a over sine A equals b over sine B. So all I'm going to do now is substitute these numbers into that formula in which I've got x equals sine 42 equals 8 over sine 57. And now what I need to do is solve this equation. Now to solve this equation, all I need to do is take the sine 42 over to this other side, or you could cross multiply. I tend to go for cross multiply only because it for when we're trying to find angles, it kind of makes a bit more sense. So for this, if we just cross multiply, and again, your teacher and your method that you may have done at an earlier level might be slightly different, which is not a problem. So here we get x sine 57 equals 8 sine 42. I take the sine 57 over to the other side, so I get x equals 8 sine 42 over, and it's going to be sine 57. And what I'm going to do is I'm going to now type this into my calculator, in which what I get is 8 sine 42 over sine 57, press equals, and I get an x value of 6.4 centimeters to 1 decimal place. So as I said, at this particular stage here, what I would do is I would cross multiply, because what you've got is you've got a fraction equals a fraction. So at this point here, just multiply this numerator by that numerator by this denominator, and you end up with this line here. And then what you want to do is try and solve it for x at that point. So moving on to example 4, which we've got here. So again, I'm going to start by labelling my information being given in the question. So here, x is an angle, so I'm going to label that as capital A. Opposite side is lowercase a. Here we've got b, and I'm going to label this as lowercase b. So as you can see, just from straight off, I've got two sides, two angles, so I'm going to use the sine rule. But I'm just going to go into the notion of labelling these points. So I've got capital B is 96, lowercase a is 7, lowercase b is 96. So writing down the formula, so I've got sine A equals b over sine b. Now substituting numbers in, I've got 7 over sine x equals, oh, made a mistake there, just noticed, capital B is, no I haven't, I'll label B is twice, is 12, that should be, oh let's do this again. So So let's start off by labelling the sides and angles. So here we've got x, which is an angle, so I'm going to start off by labelling that capital A. Opposite side is going to be lowercase a, and this is going to be angle B, so this is going to be lowercase b. So then writing down the information I've been given, I know that the angle A is x, the side A is 7, angle B is 96, and the side B is 12. So again, two sides, two angles, which equals the sine rule. And what I'm going to do is start by writing down the formula. So A over sine A, B over sine B, and then substitute the numbers in. So what I've got is I've got 7 over sine x equals, and it's going to be 12 over sine 96. Now, if you use the variation of the sine rule where you've got the sine at the top, then again you can just do what we did normally. But one way of what's easier than learning two formulas is learning one formula. So all we're going to do here is cross multiply. So if I just multiply this by that and that by that, then what we get is we get 7 sine 96 equals 12 sine x. Now, although the x is on the right hand side, it doesn't really make a difference. So what I'm going to do is I need to make x a subject. So I first take the 12 over to the side, so I end up with 7 sine 96 divided by 12 equals sine x. And then to work out what x is, I need to do the inverse sine of 7 sine 96 divided by 12, which equals x, in which if I enter that into my calculator, again not rushing this because again we don't want to make a silly mistake, which can easily be done because we're trusting all the maths to be done on your calculator, and type that into your calculator, the correct answer you should have is 35.4 0.65 I should say. Again, prime example that making a misreading a calculator can easily be done. So we get 35.5 degrees to 1 decimal point. Now, moving on to example 5. Now, example 5 might look very, very similar to what we've done so far, especially as the fact that there's an x missing. So what I'm going to do is I'll just write down what x value we're going to be asked to find. So let's find this here. Now, let's have a look at typing this into the calculator. So from this diagram, we can see that this angle here is obtuse. And let's have a look if our calculator gives us just that. So from this, we're going to establish what rule we're going to use. So start by labelling our triangle. So we're going to label this as capital A. That's going to be lowercase a. This is going to be B. That's going to be little b. So here we've got A equals x, little a equals 5.4, B equals 32, and B equals 3. So again, we're going to use the sine rule. So substituting our numbers in, again in writing down the formula, we've got A over sine A equals B over sine B. So substituting numbers in, we've got 5.4 over sine x equals, and then we've got 3 over sine 32. Cross multiplying, we get 3 sine x equals 5.4 sine 32, emphasize the dot, and then we get sine x equals 5.4 sine 32, all divided by 3. We're going to do the inverse sine of 5.4 sine 32 over 3, which equals x. So here we get x equals, and typing this into my calculator, 5.4 sine 32 over 3. We're going to answer of 72.5 degrees to 1 decimal place. Now, the problem with this is that although these diagrams are never drawn to scale, it's quite evident that x is an obtuse angle. Now, this angle that we've found is acute. Probably a poor choice of colours there, so let's just get rid of that. So as you can see, that this angle that we've found is acute, whereas the angle that I'm looking for is obtuse. Now this is what we call an ambiguous case. Now the reason for this is, if I just get the wording of that obtuse out of the way, is I could, although this side B is 3 centimeters, I could draw a 3 centimeter line here, making this into a right angle triangle, and lo and behold, that even though this is 3 centimeters, this angle here is acute. So this angle, so even if though this side here is 3 centimeters, it could be drawn there, in which this is acute and this is obtuse. And this is what we call an ambiguous case. So this is where you could draw this triangle in 2 different ways. You could draw it where angle X is going to be obtuse. You could also draw it where the angle is acute, where angle X is going to be acute. And again, based on the information that we've been given. So the question is which one do we use? Now, in a question, they'll either give you the diagram, in which they will know, although these diagrams aren't drawn to scale, if it shows an obtuse angle, you are finding an obtuse angle. If the diagram shows an acute angle, you are finding an acute angle. The size of it might differ, but the type of angle will always be the same. Now, in this question, they would either specify, if they've not given you a diagram, they will tell you to find the obtuse or the acute angle, but we go from there. So what I need to do from this is, as X is obtuse, I need to do 180 minus the angle that the calculator has given me. Now if I type that into my calculator, so I do 180 minus 72.5, it gives me an angle of 107.5 degrees. So this here is the actual angle, that is not. So it's worth just taking a little bit of extra care to recognise and have a look at the validity of the answer that you're getting on your calculator. And as I said, if you're not too sure about these types of questions, if you just Google or look through your GCSE revision guide on this particular topic, have a look for ambiguous cases, and this seems to be the case. You will never find this in cos questions when you're using the cosine rule. This only ever comes up when you're using the sine rule question, and one of the reasons why is when we move on to looking at trigonometry graphs, which will make perfect sense as to why this happens. So hopefully this all makes sense and rejigged a bit of your memory on using non-right angle trig and using the cosine and sine rule. And like I said, if you have any questions or require a worksheet on this particular video, feel free to drop me an email at 162maths@gmail.com.